Okay, we've got an average speed of 2.2 seconds, and so we can use the formula speed is equal to distance over time, but we're asked how long did Aaron run for, so we need to rearrange this to, first of all, speed times time is distance, and therefore time is distance over speed. You might have learned this formula in a different way, but I would strongly recommend learning how to rearrange. I've then got my distance, 5 kilometers, and I've got my speed, 2.2 meters per second. The first thing I need to do is change it to the same unit. So this is going to be 5,000 meters, and now I could do my calculation. 5,000 meters divided by 2.2 meters per second, and that will give me my answer in seconds. Okay, I get quite an awkward answer, 2272.72. And that is in seconds, so I then need to convert that into minutes. First thing to do is divide by 60 to work out the total number of minutes. It's going to be 37.87 minutes. 87 recurring minutes. So that's 37 minutes, but it's not 87 seconds because I've got to remember seconds goes up to 60 and then it becomes a minute, but this is in decimal notation that goes up to 100. So I'm going to minus the 37. Okay, and then to get it back into seconds, I need to times this by 60. And I'm back to 52.72. It's to the nearest second. .72. So it's actually going to round up to 53 seconds. Just be careful with that sort of question. I like the way I've done it. I've got the seconds, I've worked out the minutes, I've separated the minutes, and then I've got back to the seconds from there. All right, now we've got a lower and upper bounds question to deal with because we're measuring distances and times to different degrees of accuracy. All right, average speed is going to again equal distance over time. Now, if I want to find the lower bound of the speed, I'm trying to actually, I know what I'm going to do. I'm going to call it speed lower bound. Right, how am I going to get the smallest possible speed? Well, it's going to be if I have the smallest possible distance and I divide by the biggest possible time. So I want to divide the smallest thing by the biggest thing. Hopefully that makes sense. The fact that if I run a shorter distance in a longer time, I'm going to be going at a slower speed than if I find the upper bound, which is if I go the furthest distance in the shortest time. Okay, I then just need to figure this out. So the shortest distance, right, 53 kilometers to the nearest kilometer, so it's going to be 52.5. And then for the upper bound, it's going to be 53.5. Now the time's given to one decimal place, so the longest time that it could have taken would be 2.75. That's the upper bound because we've rounded to one decimal place. I know it can't equal 2.75, but we still call that the upper bound. We say anything less than that would be possible. Be careful about that because sometimes people want to write 2.74 and it's not 2.74 because it's 2.749999, as many nines as you want. Similar for the time lower bound. Okay, this one can equal 2.65 and we're basically there now. Just realized I've not really left enough space, so I'm going to move this one over here, this one over here. Okay, 52.5 divided by 2.75. is 19.09. Give your answers to 2 decimal places. Careful here. 19.09 looks fine. And then for the other one, we've got 53.5 divided by 2.65, which is 20.188. Which will become 20.19. And that's it. Just be really careful on this question not to use the upper bound of both to get the upper bound of the speed like that. I think that's quite an easy mistake to make, but hopefully it makes sense that if you divide by something smaller, then you'll get something bigger